Hello, hi, welcome back to another educational video. After a number of days, I am doing this video and this is regarding respiration in plants in 11 NCERT bio book. And first step of respiration is glycolysis, which is done in cytoplasm, in which one glucose molecule gets converted into two pyruvic acids. Let us see how this is getting produced. So here glucose is taken. This is getting converted into glucose 6-phosphate. How this is converted? Here 1 ATP is breaking down to produce ADP and inorganic phosphate. This inorganic phosphate is added here and it is forming this glucose 6-phosphate. Now this glucose 6-phosphate is getting converted into fructose 6-phosphate in the next step. Now this fructose 6-phosphate again it's getting converted into fructose 1,6-bisphosphate. And here how this is getting converted? Again 1 ATP is breaking down into ADP and the inorganic phosphate that is utilized by this fructose 6-phosphate and it is becoming fructose 1,6-bisphosphate. Now this fructose 1,6-bisphosphate is getting converted into two 3-carbon compound. One is glyceraldehyde 3-phosphate, another is dihydroxyacetone phosphate. And you can see here they can be interconvertible. This dihydroxyacetone phosphate is getting converted into glyceraldehyde 3-phosphate and two of them they are entering into these further steps. Now here whenever this glyceraldehyde 3-phosphate it gets converted into 1,3-bisphosphoglyceric acid and here one you can see here I'll be writing here 2 NAD plus gets converted into 2 NADH plus H plus. Because 2 of glyceraldehyde 3-phosphate I have taken, because 1 dihydroxyacetone phosphate gets converted into glyceraldehyde 3-phosphate. Now 2 of these 1,3-bisphosphoglyceric acid will be further converted into 2 into 3-phosphoglyceric acid. Here you see at carbon position 1 phosphate group was there that will be utilized for the production of ATP. Now here you write 2 ADP will be converted into 2 ATP. Everywhere I will be writing 2 because 2 molecules are entering for further steps. Now these 2 3-phosphoglyceric acid they will be converted into 2-phosphoglycerate and here in this step 1 H2O is released and these 2 phosphoglycerate will be converted into phosphoenol pyruvate. Now this 2 into phosphoenol pyruvate further it will be converted into 2 into pyruvic acid. Now here you see 1 phosphate group was here and now in the pyruvic acid no phosphate group is there. Now where this phosphate group went, here again 2 ADP, those inorganic phosphate will be used and they will produce 2 ATP. Now let us calculate the net ATP calculation and the gross ATP production. Now you see here in this step 1 ATP is used and here in this step fructose 6-phosphate to fructose 1,6-bisphosphate another ATP are used. So how many ATPs are used? ATP is used is equal to 2. Now how many ATPs are produced? In this step 2 ATPs are produced and here one step 2 ATPs are produced. Now how many ATPs are produced? 4. Now what is the net gain of ATP? net gain is equal to 2. Now let us see, here those 2 NADH are produced. 1 NADH is equivalent to 3 ATPs, and this will be produced in ETS, electron transport system. Now here 2 are produced, so 2 NADH will be equivalent to 6 ATPs. Now what is the gross ATP production? Now gross production of ATP in glycolysis is equal to 8. So net production of ATP or net gain of ATP is 2, and net gross production, total production is 8 during glycolysis. And you have seen how this glucose, by undergoing different steps, it is producing 2 pyruvic acids, and glucose is 6 carbon, and here pyruvic acids, those will be produced, each will be 3 carbon compound. Thank you very much.